Sure.
I got 6x squared plus 57x plus 27.
Okay, not too bad. Let me just go to a more difficult one here and have you do a couple. We're just sort of checking the box here to make sure you get to see a few of these before we move past it. So same thing here. If you could FOIL this for me.
Okay. It's 32. $18M. Okay, that.
Okay, what is your final answer?
36m squared minus 50m minus 16.
Should be plus 16. Minus 2 and minus 8 give you plus 16. Okay, so let me have you do just one more here, and then we'll move to a new topic. Just keep track of those signs. That's sort of critical here. All right, so let me, again, same instructions here. If you could FOIL that, please.
Okay. Okay, I got it.
All right, hang on just a second. I'm going to look at the answer here for you. Okay, go ahead and tell me.
Negative 35n squared minus 53n minus 20.
Good. Okay, so your FOILing is good. Great. All right, now I'm gonna just put something in front of you here, and I have to do it in pieces. So let me do it here. So we're gonna do some triangle stuff today. And what I want to, I guess, start with is like, how many of these squares and square roots do you know? Do you feel like you know all of these?
Yeah.
Okay. And here's kind of the most that I would expect you to know as a student. I think going up to past 12 is reasonable, like 13, 14, 15. And this is where it's kind of in a gray zone. You could say, well, maybe you don't need to know all those. But at some point, but you do need to know some of these, and you need to know them like the way you know your multiplication tables. Now, another one that you will need to know that's not necessarily part of triangles, but it's part of exponents is your cube roots, your cubes and cube roots. So numbers cubed, and then the cube root of those numbers. And the reason you want to know these is for speed. You want to be able to quickly be able to answer some questions that I throw in front of you. So these are on my website. I can also direct them to you in the email. But the reason I'm bringing that up is you're going to get some problems where at some point you're going to be asked to reduce a square root, something like this. And it'll just, in terms of like what we're doing, it's just reduce or simplify. But in the question, there'll be something else around it. But do you know how to reduce this this number right here, the square root of 8?
No, I don't.
Okay. Do you remember the very first prime number?
3,
2.
2.
Then
Okay.
3, then 3, then 5, then 7. And you generally don't have to go past this. Is 8 divisible by 2?
Yes.
2 times 4 gives you 8. And then 4 is also divisible by 2. Okay. Now, the way I teach this may be different than you've seen is you circle any pairs. And for each pair, you bring a 2, or in this case, a 2, you bring a 2 out. So it's 2 square root, and then whatever's left over goes back inside the box.
Okay, that's cool.
All right. Now, if that made sense, let's try the square root of 12 together. Is 12 divisible by 2?
Yes.
Okay. 2 times what number gets you to 12?
6.
6, and then 2 times 3 gets you back to 6. Are there any pairs?
2.
There's a pair of 2. So you bring a 2 out. 2 square root, what's left over? Just the 3. See how that whatever's left over goes in here? Okay, now I'm going to leave this example up. I want you to try the square root of 20 for me, please.
Okay. Six. Okay.
What is your final answer?
2 square root 5.
2 square root 5. Good. Okay. Now, sometimes you choose a number where 2 doesn't work. And that's why I asked you what your prime numbers are. So 42 does not go into 45, but 3 does. 3 times what number?
5.
15.
Oh, okay. I didn't. Sorry.
You meant 15. Then you try 3 again. 3 times 5. Now these are all prime numbers. So this is like there's words for this, like these are the leaves, these are the branches. You need to make what's called a factor tree. Okay. And you know you're done when they're all prime numbers on the outside. Now, because there's a pair of 3s, you bring a 3 out. So it's 3 square root. What's left over? 5. Okay. All right. So let's look at another one here. Okay. Does 3 go into 125? And if you forget your divisibility rule for 3, you add up the numbers, which in this case is 8, and that number has to be divisible by 3. Is 8 divisible by 3?
No.
No. So 3 does not work. So what's the next prime number after 3?
5.
5. 5 does work. And then you try 5 again. Now we're done because we've got all prime numbers on the outside. 1 is not a prime number, by the way. Okay, circle your pairs. Bring a number out. 5 square root 5. Okay, so let me have you try one here. I want you to reduce the square root of 75, please.
Okay. Okay, I didn't do it right.
Okay, what is the first prime number that works?
3.
Okay, so 3 times what gets you back to 75?
25.
Okay, 25 is not divisible by 3, so you go to the next prime number. Is it divisible by 5?
Yes. 5 times
Okay,
5.
now there's a pair. Now the pairs can be at the bottom. I didn't tell
Okay,
you that, but I wanted to see if there was a little bit of self-discovery on that. So you take a 5 out. What's left inside?
3.
3.
Okay.
You've seen this before. You just don't remember it, or you didn't do very much of it. I mean, this is not a life skill. I mean, let's not pretend like you're ever going to walk down the street and someone's be like, "Hey, what's the square root of 68?" Okay, but you got to do it for this test. So, like, that's why we're doing it. Okay, this one is divisible by 2. Go ahead and try this one, please.
Okay. Okay.
What is your final answer here, if you've got one?
2 square root 17.
So why did you stop at 17? What is important about 17?
It's also a prime number.
Yes, yes, very good. All right. Now, I like to bring up things that you're familiar with. So, let's say you're playing basketball, and they put a much smaller opponent on you, and you get the ball. What are you going to do?
Take
Take
go
him, okay? And you're going to score. Come down the floor again. They put same guy on you. What are you going to do when you get the ball?
the same thing.
Because you keep doing the same thing until it doesn't work most of the time. Okay, and that's what you got to. That's what we're doing here. We know the prime numbers 2, 3, 5, 7, so on. You just try 2 until it doesn't work anymore. Okay, then you move to the next number and you see if it works. Okay, so you just keep trying that number. You try the number over and over again until it doesn't work. Then you move to the next numbers. Okay, it's very iterative, this process. Now there's a pair of 2s, so you bring the 2 out. You just have to watch. Don't worry about getting this down. It's okay that there are 2 numbers left over. They go in here, but you end up multiplying them. 2 square root 15.
Okay.
Okay, so if there's anything left over, you multiply it. All right, but why did I bring that example up? Well, let's look at the square root of 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Do you see how you just keep trying to, we're finally down at the end here. Now there's more than one pair this time. So for each pair, you bring a number out. Okay, so you're going to bring a 2 out and you're going to bring another 2 out, but there's a 2 left over. So you have 2 out from the first pair, 2 out from the second pair, square root of 2. This reduces to 4 square root 2. So you multiply whatever's on the outside, and if there's stuff left on the inside, you multiply that as well.
Okay.
Any questions on this? Because I want to give you one to do on your own.
Nope, that made complete sense.
Okay.
Dang it.
All right. So try square root of 40, please.
Okay. Okay, 2 square root 10. I got the answer.
Sorry, I was muted. Yeah, good job on that. Let's look at this next one together. What is the very first number that you should try that works?
Or I tried 3.
So what is 1 plus 3 plus 5?
That's 9.
And that's divisible by 3. So we know that works. Now, how's your division when you don't have a calculator?
It's okay. If it's
Okay.
like
Now, if you need to in our lessons, you can use the calculator because time is kind of premium, but when you're doing this on your own, it would be better to work it out by hand. Maybe that doesn't make sense, but
No,
you know.
it's
So we try 3 again. What number goes here? Can you tell me that?
15.
Okay, and then you just keep trying it, right?
Yep.
Eventually. So you bring a pair of 3s out, we bring a 3 out, and what's left over on the inside is
15.
15. Okay. Let me have you try this one on your own. And then we'll just move to the last kind of difficulty. And we are going somewhere with this. We are going to do some prep questions, but this is a skill you just got to build up. So go ahead and try this one on your own, please.
Okay.
What is your final answer?
3 square root 22.
Yes, that's correct. Okay. All right. So I'll show you how I'm able to check those quickly later on. That might be a useful skill. Okay, so let's look at this one together. You have to start in this order. Like don't try to start with 3. Probably a better example is when it's divisible by 10. You got to use the prime numbers, and we get into why, but you don't need to know why. I mean, you just want to know how to do this, but you will be more successful doing it this way. So 2 and 36, 2 and 18, 2 and 9, 3 and 3. Now you can have more than one pair, and the pairs can be different numbers, but whatever your pairs are, that's what you're bringing out. So you're bringing out a 2 and a 3, and what's left over is the 2.
Okay.
Okay, so this is very repetitive. So let me have you try this one, and if you get this, we'll move on to some other problems here.
Okay.
What is your final answer?
I got 6 square root 3.
Yeah, that's correct. Okay, great. All right, so now we're gonna move on to some triangle problems. So I'm gonna put something in front of you. Have you seen this before?
Yes.
Do you know what this is called?
Something theorem. Yeah.
Yeah. Old dead guy. Good old Pythagoras. Yeah, Pythagorean theorem. Okay. Don't worry, they don't ask you to fill in the blank on the math section. Okay, now very important here. A and B are the legs. You have 2 legs. Okay, so do I. They come out from what's called this vertex point. A and B are the legs. They are always the shorter sides. C is the hypotenuse. C is always across from the 90-degree angle. This is needed for you to know that it's a 90-degree triangle. Any questions on that, or anything you want us to review on that part?
Just to make sure I don't forget this.
You have to remember that A and B are the legs, even if they are, well, we're going to get into some confusing examples, but you want to remember this as A and B are the shorter sides, which are the legs, and C is the longest side, which is the hypotenuse. So that means A and B are always less than C. Again, we're doing more like worksheet review today. We're going to get to some problems, but you're going to get some on the test. And I feel like these are the ones that you should be able to do. So that's why we're attacking, triangles and roots and stuff today. All right. Okay, so here is a kind of a worksheet problem here. If A is 6 and B is 3, solve for C. So here's A, here's B, and they want C. And A squared plus B squared equals C squared. So you have to be able to square quickly. What is 6
Yeah.
squared?
36.
3 squared
9.
equals C squared. You have to be able to add quickly.
45.
And then you have to be able to take the square root of both sides. So now you know how to do that. So go ahead and reduce that for me, please.
Okay. Three. 3 square root 5.
Yes, 3 and 15. 3 and 5, yeah. So C is 3 square root 5. So on your standardized test here, they will not give you the square root of 45. That will not be there. This will be. They won't give you like the unreduced form. So like that's why you have to know how to do this, because you can know how to do it to this step, square root of 45, think you're done, answer's not there. All right, let's do, so here's how the problems get more difficult. This is important for you to see. So this time there's no A, B, and C. There's L, M, and N. Okay, but this is really like A, and this is really like B, and this is really like C. But I wouldn't write that. I would remember the words. I would remember that it's the leg squared plus the leg squared equals the hypotenuse squared. Okay, because what you really need to do is be able to put the numbers in, square them, and take a square root. So this is 5 squared plus 10 squared equals n squared, because n is the hypotenuse. 25 plus 100. So you have to be able to take the square root of 125. Will you do that part for me?
Yes, sir. Five, 25. 5 square root 5.
Perfect. Okay, and again, there will be no questions this simple, but these lead to the types of questions you will see on the test. And we got to be able to do this basic skill here. Okay, so this is we'll move to the different type of question, but I'd like you to solve this one on your own, please.
Okay. Okay.
All right, what do you got for me here?
I got 13 square root 2.
All right, and how confident are you in your answer?
Not very, but yeah.
Oh, that's you should have more confidence. You did that one completely correct.
Let's go.
All right. So let's do the other case in here so you can see that. All right. So in all the examples we just did, I was giving you both legs. You may not be given both legs. You may be given the hypotenuse. In this case, this is the hypotenuse and a leg. And you still want to use this a squared plus b squared equals c squared. So this is 10, this is 12, and it's up to you if you want to use c, but what you don't want to do is like put it in the wrong position. So I would just keep writing a squared plus b squared equals c squared, but either change this or say, okay, it's really the two legs. So it's 10 squared plus c squared equals 12 squared. I don't know if that's clear or not, but leg,
Yeah.
hypotenuse. Is that okay?
Yeah.
Okay, and now you got to subtract. So c squared equals 44. And guess what you're doing yet again? You're taking yet another square root, 2 and 22, 2 and 11. So c is 2 square root 11. All right, so let's have you just try one of these, and if you get it, we'll move on to a different topic, something completely different for the rest of the hour.
Okay, I got it.
All right, what is your final answer?
4 square root 14.
Yes, that is correct. Yeah. Okay, very good. Why don't you take just 1 minute to refresh, reset yourself here, and we're going to move into some other stuff here. So I'll check back with you in about 1 minute.
Okay.
All right, pretty much at a minute. Did you try the question of the week?
It didn't load Monday. Like I just had a blank piece of paper. Maybe I scrolled off of it, but I don't know what I did.
All right, that's okay. Well, let's look at it together. This is always good to do. And then we'll move to some story problems in case you want to look at this later. So if a squared plus y squared I minus 3 times minus 6 plus 8i equals 4 plus 10i, where I equals square root of negative 1, what are the values of a which satisfy the given equation? So this looks pretty complicated. potentially.
Yeah.
We want A right there, right? And what you probably don't know, or you don't really even care about, is that this is a complex value equation, but there's a real part. There's the real part. Okay, and then there's the imaginary part. Okay, and why does this matter? It really doesn't, but it's a problem you might see on a standardized test. So we're just gonna work on the left hand side though for the moment. It's a squared plus y squared I. You can drop the parentheses because there's no operator out in front, but on the right here you have to multiply this -3 into both of these. So
Okay.
it's plus 18 minus 24i. Okay, so the a squared and the 18, they're the real parts. If you were to just reorganize this equation slightly, just writing it out here, this is real and this is real. This is imaginary and this is imaginary. So you would set the real part equal to the real part. So you'd have a squared plus 18 equals 4. What do you do to solve this equation?
You bring the 18 over.
Yeah, so you're going to subtract 18 from both sides, so it's -14. When you take a square root of both sides, this is where that given, and you've seen this before, I equals the square root of -1. At a minimum, you should know that means your answer is going to have a -1 in it. So the square root of -14 is really -1 times 14. Like an extra number in there. So this square root of -1, that's what becomes I. That's I times the square root of 14. This one you try to break down like we've been doing, but there's nothing to break down. It just becomes that. So the square root of -1 becomes I, like that.
Hmm.
Do you think you could do one of these on your own?
Can I ask a question before I try
Of
it?
course. Yeah, absolutely. I always ask your questions. Yeah,
But how do I determine how do I determine how it's real or and imaginary?
that's really important here. I didn't cover that, and that's great. So the real part does not have any I's in it, but the imaginary part, what does it have?
I
I's in it. And another kind of the sneaky thing in this problem is that there's this subtraction symbol. You're supposed to distribute the negative to both. That's what students forget. That's why this problem is here, is because there's a lot of there'll be at least one question where you have to distribute a negative to the to both terms. Okay, so having said all that, let me pull up the practice set for the week. I think this is 17. Yeah, 17. Okay. So any other questions? Because I'd like you to try one on your own. You good? Ready?
yeah.
Okay, great. All right. Go ahead and have at it. If you have any questions, let me know. How are you doing on this one?
Almost to the point where I can't do anything. So I'm being a little slow.
All right, so let's start. It's the same set of steps. So you're going to write x squared plus a squared I. Sorry, like that. And then you're going to distribute this -4 in. So it's -4 times -18. That's positive 72,
Yep.
positive 4i. Did you get that?
Yes.
Okay, so this is real, and this is real. Now you can regroup the terms, but you don't have to. Did you write x squared plus 72 equals -17?
Yep. And then I subtracted the 72.
Okay, now this is a good place to start looking at the answer space, because you're going to take a square root of both sides, obviously. And so there's a square root of -1 in here. So your answer is going to have an I in it. So that one's out. And then the question is, well, can you reduce 89?
No.
And the answer is, well, no, but like one of the things you should notice is that if you could reduce it, there'd be something on the outside here. There's something out here, but there's not. So this is why this is the correct answer without even like having to spend much more effort to do it. Now, does that always happen? No. Where did you get stuck? Was it this part right here?
Oh, I didn't mean stuck. I meant like I was like almost done, like to the point where I couldn't do any more work to where I had the answer.
Okay, okay. A miscommunication. I thought you meant you didn't know
I
how to do it.
it's stuck. But I had the same thing, everything written out. It's just I didn't get to the I part where I had the I in front and the plus and minus.
All right, so let me have you do this one here on your own, and I just want an A, B, C, or D. That's the goal here. So, and you can start anytime here.
Okay. Okay, I have the answer.
All right, A, B, C, or D.
E.
You say that as if you don't think you have it right, but you do.
I'm just
You gotta have more
I'm,
confidence in your answer. And so I'm gonna be, I'm gonna be more, serious and direct now. Is like when you get to the test, you want to have full confidence in your answer. I know we've talked a little bit about like if it's A, your second, you should check it again. Yes, that's true, but confidence is key. Okay, you really want to like go into the test and be like, I got this. Put an answer down, and I got it. But because the difference is now you're going to have spent at least 4 weeks with me doing 2 lessons a week, and you've been practicing on your own. You're more prepared than ever when you go into this in a couple of weeks. So I need you to have a little more confidence when you're giving your answer. It's okay. It's not like it's not, you are humble, but you know if you're doing the work and you know what you're doing, yeah, it's B. I got it.
okay.
Any questions on that type of problem?
Nope.
All right. Let's quickly move to some statistics questions. This is what I wanted to get to that I didn't quite have time for. yet. So let's, these are some story problems. We're gonna have to read them. And yeah, there's a lot here. So we'll just go through as many as we can, but definitely want to do these. So, all right, at a primate reserve, the mean age of all the male primates is 15 years, and the mean age of all female primates is 19 years. Which of the following must be true about the mean age M of the combined group of male and female primates at the preserve? Okay, so they're saying that all the males, and sometimes it's better to write, the male average is 15, the female average is 19. But they're saying if you combine them, if you were to combine these, what is the most reasonable answer here? Is it that their combined average is 17?
No.
That and you should be saying no, because of, like, if it's A, you better be questioning it. Yeah, if it's not A, which one could it, maybe should it be? If you're not sure. Are you sure? Not sure? What do you think here?
I have no idea.
Okay. Okay. So this is where, like, you have to know a little bit more about averages. All right. And so let's say, for example, there were three males, 14, 15, and 16. What is their average?
15.
Okay, agreed. Now, what if there was an 18 and a 20-year-old female? What is their average?
19.
Okay. Now, the question is could the average be right in the middle? Yes. Yes, it could be. Yes, it could be right in the middle, but we don't know how many there are. Okay, we don't know how many females there are, because it could be that there's a 10-year-old female and a, what do I need here? A 38-year-old female or 28-year-old female. Because that averages out to 19 as well. And so what's going on here is that since we don't know how many there are, all we know is that the average must be between 15 and 19, because the males pull the average down, the females pull the average up, but we don't know where it is in the middle.
Okay.
And I wish there were another way to sort of ask that question, but there is definitely not here.
No, that makes
All right, now the next question here, what I want you to do first, and really think about this rather than staring at the table, is I want you to read the question or the thing it asks you to do first. I want you to read that out loud for us.
the table below shows that.
Nope, stop. We got to start. I want you to start right there.
What was the mean low temperatures in degrees Fahrenheit during the 5-day period?
Do we want low or high?
Lows.
Okay, so you're looking at this row right here. Do you care about anything else?
No.
No, so don't read anything else. So you've got a calculator, add these numbers up, okay? Now, if you're using a calculator, it's a good idea to put parentheses first, because you want to add them all up and then divide by 5.
54 plus. I got 48.8.
So letter A, right?
Yeah.
And it's letter A. So are we any concerned there that we've done it wrong?
No.
Because we know that we did it the way that we're supposed to. Perfect. Okay. All right. Now there's some averaging techniques that we can do that I'll tell you if I think there's gonna be more averaging questions, but doesn't look like it here. All right, next question here.
Read the question again first.
Yeah, so we'll just do it together. So based on the histogram above of the following, which is closest to the average or arithmetic mean number of seeds per apple? So before we can answer that, we need to know how to interpret this chart. All right, so there's 12 apples total, and that's very important here. There are 2 apples with 3 seeds in it. So your data set is actually 3,3. There's 4 apples with 5 seeds in it. So that's 1, 2, 3, and 4. And then same thing down here. So for 6 seeds, there's only 1. How many 7 seeds are there?
2. So there'd be
2.
two.
And then there's no 8s, but there's 3 9s. So 1, 2, and 3. Okay, so if you want to find the average, you have to add up all of these numbers and divide by what?
The amount of apples, so 12.
Yes. Okay, and again, please put that in parentheses before you add them up. So go ahead and do that for us, please.
Okay. Okay, 3 plus 3 plus. At 6.083 repeating.
So this one says which is closest.
So 6.
Yes. All right. So final thought for today is that sometimes, well, we'll get to that next time. We'll just talk about that next time. I don't want to get into that, but I'll leave a little note here. All right, well, that does it for today. Do you have that ACT prep class coming up this week, or is that still?
Yeah, we got it. We got it tomorrow at from 5 to 6 or 6 to 7. I think I'm gonna go to the 6 to 7 one.
Okay, great. Well, thank you so much, and I'll send you the notes here shortly, and I'll see you on Thursday.
Thank you so much.
Have a good night. You're welcome. Bye now.